Good afternoon, everyone. Thank you for your time today. My name is Grimm, Consulting Solutions Architect at ZEDEDA. What we do is bring the cloud operating model to the edge. There's 75 billion edge devices that are going to be around next year. People say cloud or edge is the new cloud and all of that. We're just extending that operating model and empowering our customers to run cloud-like applications at the edge. I've been in the industry for a long time. I've been deep networking and security guy, Cisco, Dell, AWS. Most of the folks at ZEDEDA are cloud background, and I've been doing edge for a few years now. So thank you for your time today, and we'll get started on this next use case. Okay, so 21 billion. That's a big number. Hold that in your mind. We're going to come back to it. So one of our global shipping customers, they own or charter over 600 vessels. I think it's 644 vessels, actually. These vessels spend 20 to 45 days at sea, right? So they need to be able to run between ports for a very long amount of time, right? They visit 340 ports over 120 countries, and they ship 13 to 15 million 20-foot equivalent units. So this is 15 million containers. We've all seen container ships. It's on the Docker logo. We understand what a container is. Now, there's 600,000 to 1 million of these containers are fresh and frozen goods. They have to stay at a good operating temperature, or bad things happen. So that's $21 billion in refrigerated cargo that's at risk today. And that is a real problem for the industry, because if there's no connectivity on ship, or very little, they might have like a radio walkie-talkie kind of connectivity. There's no monitoring of the containers. They've got you saw the picture of the refrigerated container. Now, if you've got thousands of containers on a ship and you're walking up and like with a clipboard, like how well is that going to work? How well is that going to scale? And how long was it in its state before you found it? Now you're risking spoilage and shrinkage, right? And this spoilage food and creates massive costs. So their 21 billion is the challenge there. So what are the customer technical challenge? They have to maintain the integrity of the shipping containers themselves. We need to monitor whether the temperature is within range to prevent spoilage. We need to also help them ensure security so that the physical device is not breached, and particularly in leased vessels, because they don't own the vessels, so need to keep an eye on that. Connectivity, so I said they had a radio network. What they really need was a 2G to 4G to Starlink communication. They really needed to upgrade their infrastructure if they want to do some of these new cool things like IoT stream these analytics off the containers into a place where they can actually do something with the data. And they also struggle with the on-ship to onshore. So think of your local network for your radios, and then you've got kind of your local DC to back to onshore management as well. So, and like you don't have, again, this is a common theme. We don't have local IT staff on hand, or if they do, how does one person or two people going to go and check, thousands of containers, like even if they had a local IT staff, which they don't. So these are the customer technical challenges. They know what they need to do. They're blocked on several ways that, it can't be done. So again, how does ZEDEDA solve these problems? We are that cloud operating model at the edge, and we can do really cool things like read IoT sensor streams into an app running on our hardware, process that, take insights away from it, and take actions based on those temperature measurements. So I alert local staff, this cooler is broken down, go recycle it or flip it over to another power. So those real-time insights is what protects that $21 billion book of business, and loss of brand and loss of reputation. Like the customers aren't going to pay them, but they're going to have an impact to their brand and reputation as well. These devices have to be secure. We've talked about this a lot today. The remote attestation, the matching PCR hashes the the measured boot, all of that stuff you can't have, or it's really undesirable to have someone hands-on to that local edge device with any kind of access to do anything nefarious with it. So local connectivity. So this is what ZEDEDA did to solve the problems. The first project there was to help them build a local packet core. And then once the 2G was in, to upgrade that from 2G to 4G. So now they have a local, cell network that can connect all the things, right? That was for on-chip communications, and that was, step one to getting to where we wanted to be, which is to help them get to a mesh of uplinks, SD-WAN implementation. So local network basically to wide network, and implementing SD-WAN, ability to go between low Earth orbiting and geo satellites, and to manage all of that in a way that doesn't require local IT staff, so that you can get the local insights and push them out to things in the cloud as well as the rest of the fleet, right? So it was definitely a communication to think of as, again, CPE-esque, right? We're taking SD-WAN and other things and adding monitoring and management and local analysis and all that stuff. So we need to account for remote as well as out-of-band orchestration of edge devices, and again, no local IT staff. Any upgrades to those, anything that's happening in the system, anything that's happening on the edge device, we have to monitor, detect it, fix it, push the new updates. It has to be that cloud as a service model, and that's what we're building for them there. This is we're down to short on time, so I'll go very quickly here. We've got the private core network that we built. These are also running Eve on top of our third-party hardware, our partner hardware. Those connect to the SD-WAN, and they connect all the supporting infrastructure apps, like we talked about, monitoring the health and of the containers and sensors and those IoT streams. That analysis is being done there. Operations via SD-WAN links to both the fleet, the customers' NOC and fleet management, like we talked about in the rail case, as well as our NOC and monitoring. So it's a complete solution to modernize and revolutionize their business, to meet all of their standards, to keep it secure with what we put into the operating system, and reduce that $21 billion risk of spoilage down to as near zero as we can get. And that is, okay, so what's next? We're going to get into more applications and use cases around operational safety. This was first a reduced business risk for the spoilage, but there's many other opportunities to increase the levels of safety and health and safety, and that's similar to what we're doing in oil and gas and other fields, where we're making sure people have their PPE on and things. And expansion to chartered vessels. Right now, we're only working on their owned vessels, but the idea is to create a kit you pick up and drop onto a chartered vessel. When you're out at sea for 120 days, you pick that up and you take it back. So we'll be expanding to the chartered vessels as well. Here's where you learn more. Edge Field Day, GitHub repo, links to the Terraform demo and all of the set up your free account, the help center, getting started, all that stuff is there when you're interested.
Yeah.
So
maybe just to jump in on that for a minute.
Yeah.
On previous slide.
Yep.
We did want to include a number of links. So if you do go to the ZEDEDA website, you'll find links to this laundry list here. The Terraform code we showed at the beginning. Unfortunately, we got 4 minutes, so we'll post the demo on the website for folks that want to follow along. We kind of ran out of time. Great questions, by the way, thank you. We've put links to the LF Edge site, so if you want to learn more about Eve or contribute to Eve, we're an open community. Would love to have more contributions showing up. We're also connecting to Edge Monsters. Edge Monsters is a project that we've joined recently. Our CTO, Eric Nordmark's a member. We meet monthly, talk about edge topics, and publish a blog, so encourage you to follow along with that. And then there's also, if you want to try the product, you can self-serve, sign up, get yourself an OnLogic or another device and try it all out for yourself. But really appreciate the time today, really good questions. And we look forward to sort of putting that demo on the website. Hopefully you guys can follow along on that when we have more time. Any last questions before we close out and hand it to Stephen?
Is there a way to try it out without having one of the edge devices? Like if
You
we
can
had
run,
like a virtual abstraction to just try out the platform and the solution?
There are ways. So you can run like a virtualized Eve, right? We've done some work with
ESXi.
I could have Eve on Eve.
yeah, you can have Eve on ESXi.
You can virtualize it on ESXi,
Or-
Proxmox, KVM.
Yeah, exactly.
Got
So you don't necessarily need a hardware device. Also, you can buy a Raspberry Pi, very inexpensive. You can run a Raspberry Pi is a good way to try that out as well.
So as you guys mentioned,
it.
you're running, effectively in this case, you're running Rancher inside of your Z control.
Yeah, we're kind of simulating the orchestration layer of that.
And there's, I'm guessing as part of it, you're deploying the Rancher yourself.
Yes.
Is there like best practices? Is there value add of what you guys know as to how that happens, to how it gets deployed?
Yeah, we do. We help our customers on how to design that.
Cool.
For the demo, obviously, I use small instances. It didn't require a lot of horsepower, but the key is to show the end-to-end automation. There's a lot of things that come into play. Obviously, the Terraform automation, but Cloud Init and all the things we put together to finish the service chaining. Because the key is you can bring up a lot of VMs, but in the use case of when you're terminating data, like a sensor runtime that's collecting where you're sending, and then when you're orchestrating a firewall, I think you mentioned that before, where traffic is traversing, right? Those are two very different use cases, and Cloud Init plays a big role in making that happen to automate the service chain.
Yeah, and to pile on there, we've done deep API integrations with a lot of management systems. So in this example, we do API calls to the Rancher server to register, set up data flows, connected. So there's a lot of sort of day two operations that are typically done manually that we're automating through our APIs to other products.
Awesome.
Hard to show in a demo, but
Yeah, but it's part of our third-party integration. So
I gotcha.
Do we mention ZKS or no?
yeah, and good point, Jason. So we also have, as one of the services I mentioned at the beginning, we have a Kubernetes service. We call it ZEDEDA Kubernetes service. It enables our customers to quickly deploy a K3S runtime and then again connect it to their orchestrator of choice, Rancher, Rafe, etc. So that's part of our offering is a supported Kubernetes runtime that can be easily deployed. Thanks for that reminder. Okay. Demo gods the demo gremlins didn't mess too much, so I'm glad we're up and running.